Hello, I'm teacher Ivan from WUNNA Educational Services, a teacher of mathematics and physics. We are still looking at the states of matter, and in today's lesson, we shall look at the kinetic or particle theory of matter. It is commonly known as the kinetic theory of matter. The kinetic theory of matter states that all matter is made up of very many tiny particles that are in a random motion, continuous random motion, and their speed depends on temperature. So that is the kinetic theory of matter. This one can be evidenced in two phenomena. We can evidence this in Brownian motion and diffusion. Brownian motion is defined as the continuous random motion of particles suspended in a fluid. Where can we evidence this? If you get fine powder like wheat flour or plain grain and sprinkle on the water surface in a container, you realize that the powder will start to spread. That shows that the water molecules have been already in motion and they are now transporting the wheat flour or plain grain. That's a very quick demonstration of Brownian motion. But this can also be demonstrated in the laboratory using a smoke cell, using an illumination source, using a gas jar, and maybe a microscope. But locally, in our daily life, we can also evidence it in our kitchens. For those who use firewood, if at all you have a small leakage on the roof or a hole in the iron sheets, you realize that when the sun rays enter and you observe how the smoke is moving, you realize that these white particles of smoke are in constant movement around the room. Actually, it is also evidenced when dust rises. Assuming you are cleaning a class, when dust rises, those dusty molecules start moving in a random direction, in all the directions, but continuously. So that's what we call Brownian motion. Brownian motion is exhibited in gases, and it has factors. The major factor that affects Brownian motion is temperature. When you increase the temperature in the room, the speed of these moving particles also increases. Because we've seen from kinetic energy that these particles are in continuous random motion, but their speed depends on the temperature. So increasing the temperature will increase the speed of these moving particles. We can also evidence kinetic theory of matter in diffusion. For instance, when you get at home, let us try this at home. Get hot water, get a tea bag, and dip it in hot water. You realize that the brown pigment from the tea bag easily spreads, and that's diffusion. That pigment or the brownie molecules are being diffused in the hot water. And why do we use hot water? Because of the factor of temperature, where high temperature results into high rate of diffusion. So we can demonstrate diffusion at home using a tea bag and hot water. That is in liquids. In gases, diffusion can be demonstrated using a perfume. When you spray perfume in one corner of your bedroom or sitting room, after a short period of time, you realize that the whole room is having that scent of the perfume. That's because the molecules of perfume have been carried away to the whole room by the constantly moving air molecules. We have other daily life applications of diffusion. Even farting. When someone farts in class, you find that people around that area will all complain because of diffusion. Diffusion is defined as the movement of molecules from a region of high concentration to a region of low concentration. Also take an example of someone using a fire extinguisher. The carbon dioxide in the fire extinguisher is at a high concentration. But the moment you open the tap, it will move from where it is at a high concentration to where it is at a low concentration. That is diffusion. So diffusion can be demonstrated in both gases and liquids, because these two states are the ones whose particles are in motion. For solids, it is at a very, very low rate because the solid molecules are not in motion. So that is diffusion. We must know the definition. We must know how to demonstrate diffusion. We must also know the life applications of diffusion. Otherwise, that has been the kinetic theory of matter and its applications in Brownian motion and diffusion. In our next episode, we shall be looking at the molecular properties of matter, and under this we shall look at diffusion, we shall look at the molecular forces, we shall look at capillarity, we shall look at surface tension and elasticity. Those are all because of molecules. That's why we call them molecular properties. Otherwise, I'm teacher Ivan from WUNNA Educational Services, a teacher of mathematics and physics. I hope to see you when you join us.